Okay, so this example, you can do it with either the root test or the ratio test. And it depends on whether you know this result or not. If you know that limit of nth root of n as n goes to infinity is equal to, what is this limit?
1.
1. We proved it earlier, right? If you know this result, then the root test is a lot easier. If you don't know, then you have to derive this, so it takes more time, so it's actually easier to use the ratio test. Okay? So let's assume that we do know this, so we can just quickly use the root test. So root test R is equal to limit n going to infinity of nth root of n times e to the negative n. I should be putting on absolute value, but these are always positive, so I don't have to put absolute values. And then this becomes nth root of n and nth root of e to the negative n. So you can break up the limits like that. And furthermore, you can rewrite nth root as 1 over nth power, right? And what's the rule for exponents inside the parentheses and outside the parentheses?
Yeah.
You multiply, right? So you have n times 1 over n, which is?
-1.
Yeah, so you just get -1 as the result of the product. And we know that this goes to 1. So this will be 1 times e to the -1, which is 1 over e. Okay, is this value bigger than 1 or less than 1?
Less than 1.
It's less than 1. How do you know?
Because 1 over 8 is always
Oh.
less than 1. I don't know. I just know that.
Okay, approximately what's the value of e?
2.77?
2.7...
Two?
3, I think. 2.73. Yeah, 1. Yeah, 2.73. Yeah. Okay, so this, because it's 1 over 2.73, this is less than 1, and therefore it converges. So summation n equals 1 through infinity of n times e to the negative n converges by what? By?
The ratio.
No, we did the root test.
Sorry.
Yeah. Please don't confuse this. If you use if you did the root test and write ratio test, there will be points taken off, so you don't want to do that.
How many points precise?
Just 1 point.
Oh, okay.
We can't switch on